Welcome to Algebra 1, Semester 1, Section 6.4. We're solving complex inequalities now. In class, I have probably already explained to you when you see the word or, you need to think of a seal that will say or, and his flippers point out. That tells you exactly how the graph's going to look. It's going to be pointing out. Now, in inequalities, we never have a graph pointing like this. That does not happen. Nor do we have a graph pointing like this. That does not happen. The only possibility is either a graph pointing out or a graph pointing in, which if it points in, we just connect it. It's like a big hug. So this is the or. The or points out. We look at the first one. It doesn't have a line underneath it, so we go ahead and draw it with an open circle pointing that way. This one does have a line underneath, so we draw that with a closed circle pointing that way. Now we solve them as two separate problems. I am just going to use my Post-it note to cover one of those so that we can focus completely on this other one. So we have 3h plus 1 is less than negative 5. Well, the first thing I'd do to get that variable alone would be to subtract 1 from each side. So I get 3h is less than negative 6. Now to get that h alone, it's being multiplied by 3. I'd divide by 3 on each side. I would get h is less than negative 2. So that's one of my answers. Down here I can go ahead and write a negative 2 underneath that inequality. The other problem, I can cover up that one. If you ever want to use Post-it notes in the classroom, I've got them. You can use it just to eliminate some of the clutter. We want to get that h alone. We draw our line where the inequality is. There's a minus 5 by the h, so we add 5 to get rid of that. That will wipe out. We get 2h is greater than or equal to 12. Now 2 is being multiplied by h, so to undo that, we divide on each side. Division property of inequality results in an answer of h is greater than or equal to 6. So we write 6 underneath the closed circle. You've just done that problem. Good job. The next problem, see how it's all connected and there's no or? That tells us that it's going to be the connected graph, or what we call the hug, the union. Okay, so this one's going to be a closed circle. We go ahead and we draw that closed. This one's going to be an open circle. So we draw that open, and we go ahead and connect them. Now we come up here and draw your line on the inequalities, and focus in here on the variable. You're trying to get the variable alone, so it's going to run the show. What's being added or subtracted in here is minus 8, so we add 8. But this time we need to add it to every section of our problem. Negative 28 and a positive 8 will be negative 20. Bring down your inequality. We still have 2x remaining there. We've wiped out the 8. Is less than or equal to a positive 8 minus 2 is positive 6. Now in order to get that x alone, we need to divide by 2. Remember, we do that in every section. In every section. Negative 20 divided by 2 is a negative 10. Is less than x, which is less than or equal to positive 3. So we come down and we show negative 10 and a positive 3 on the graph. Those are complex inequalities. That's how we solve them. I have a few that are just a little bit more like the beginning of this unit. First thing we would do is we would distribute. So we write distributive property. We get 9p plus 12 equals 9p plus 27. Now in order to get all the p's on the left-hand side, we need to subtract 9p over here. Do the same thing to the other side. We find that unique situation where we've wiped out all of our variables. We have 12 equals 27. That is not true. So down here we need to explain this is no solution, meaning there is no real number that can satisfy this equation. Now, if you notice, we do have an extra blank up here. Sometimes that happens, but I always want you to double check that you've written down every property you used. And we neglected to do that. We did subtract 9p from each side, so we should have put subtraction property of equality. Okay? Next problem, we're going to distribute on our first step, so distributive property. 3 times 2a is 6a, 3 times 2 is 6. 2 times 3a is 6a. 2 times 3 is 6. When we go to get rid of the variables on this side, we happen to get rid of them on both sides. And so again, we know it's going to be either no solution or infinitely many solutions. Anytime we wipe out our variables, that's what it is. Because this is true, it is infinite solutions. Meaning, any real number will satisfy this equation. And again, we need to finish off our properties. That was the subtraction property of equality. Okay, down here, actually, I need to hold on this. This is a new section. This is actually section 3.8. So you've finished off this section, which was 6.4. Thank you very much.